All right, here's the bell work. So on this one, we're just going to simplify this expression. And while we haven't seen this with solving equations yet, we will. And the first thing we're going to have to do to simplify this is to distribute this 4. Now the 4 is positive because of the plus sign out there to the left, okay? So when I distribute here, that's 4 times 3x's, which would result in positive 12x's. And yeah, I got that plus sign out in the front because of the 2x. But I also have to distribute the 4 to the 5 as well. So that's 4 times 5. Remember, distribution is multiplication. And 4 times 5 is positive 20. Okay, now I can bring down the other stuff, 2x and the plus 15, okay? And remember not to distribute the 4 to the 15 because it's addition of 15, not multiplied by 15. Distribution is multiplication. So now that we have the distribution out of the way, we look to combine any like terms that we have. So I got the x's here. So how many x's would that be? 2 and then plus 12. How do we know it's plus? Because of the plus sign to the left of the 12x's. 2x's plus 12x's results in 14x's. And then the constants, 20 and 15. So that's 20 plus 15. Again, it's plus because of the plus sign in front of the 15 there. That's going to be positive 35. All right, so while it is okay to write it like this, it's possible, if you'd like to switch these around, as long as the signs remain the same. 35 is positive, and so is the 14x. So make sure you show it's positive with the plus sign, okay? Both these are correct. They have the same exact expression, just with different orders. Here's our objective for the day. I can solve equations with one principle of equality. Take 15 seconds and copy that down, please. All right, so one principle of equality. In the last lesson, we talked about using the addition and subtraction principles of equality. And remember, that was in order to make phantom zeros, because we didn't want it to have to show anything that's being added or subtracted to the x's. And since we went over addition and subtraction last time, today, our one principle of equality that we're going to be looking at is going to either be multiplication or it's going to be division. All right? But that is going to be in order to force a value to be a different phantom value, okay? So just a quick review. Remember, equations versus expressions. Equations just have an equal sign, and it's usually a comparison of expressions. So remember that the equal sign, sometimes it can still show falseness, right? Like if we said, hey, let's make this 10 equals 11 right there, okay? This is a false statement. The equal sign can stay, it's just a false statement. If I change this just a little bit, instead of having that 1 in the ones place value, make it a 0. Now this is a true equal statement, okay? And remember as well, it's possible that we don't necessarily need to show this as 10. 10 can be whatever you want it to be. Sometimes we make it like 9 plus 1, okay? In fact, you could even make it like 19 minus 9, right? So 19 minus 9 here, and that would still be a true statement because 19 minus 9 does actually equal 10. Now, since we're looking at equations and we're solving the equations, we want solutions to the equations. Remember, it's like saying, hey, look, we're going to make that, instead of a 19, it's going to be an x. And then we have to figure out what value of x would make this true. In this case, just like we saw barely, if we made x equal 19, then it would be a true statement. So this brings us into what is a solution. So for that last example, 10 equals x minus 9. And of course, we would use a principle of equality to solve this one, but we know that if you replace x with 19, that would make the original equation true. That's why we call this a solution. All right, x equals 19 is the solution. Now, it's just the solution for this equation. So we may see other equations where it's the x, but it would equal something different, and it would still be true for that new equation, okay? So it's possible to use the same letter or the same variable in different equations and get different answers that way. And remember, for the homework or even for assignments or classwork, sometimes it just say solve for x or solve. What it's really asking is what value of x makes the equation a true statement. In this example that we saw, we found that x equals 19 would make this a true statement because 19 minus 9 actually does equal 10. And along those lines, there's right now we're only looking at equations that have one solution. And it's this one, which means if you deviate from this at all, if you said x is equal to not 19, whatever the number is, negative, fraction, decimal, doesn't matter, it would make this equation false. And then we get a false statement from the equal sign. So here's our principles of equality. Now remember, addition and subtraction is to make zeros. Multiplication and division is where we are going to make a phantom value, okay? So we're going to force a value to be a phantom value, but the only phantom value we can get with multiplication and division is phantom ones, okay? Now, how do we get phantom ones from values? Now, think about it like this. Remember, this is saying that if you got something that equals something else, they may not look the same, but they are the same. This is equal. They're equal in value. If you multiply both sides by the same thing, you still have a statement that's still true. Or if you say, well, you got two values that are the same, whether it's like x plus 5 equals 19, if you divided both sides by the same thing, you'd still maintain a true statement, okay? But again, we only use these to make phantom ones. So for example, okay, let's look here in the bottom. For example, if you had a number like, I don't know, 27, okay? Let's say you wanted to make a 27-1. Well, what you'd have to do is you'd have to divide it by itself. And then you would get a value that's 1. Okay, if you divided 27 by itself, you get 1. Anything divided by itself is 1, okay? And so we see kind of a repeat of these values, right? So 27 divided by 27 is 1. Just like we saw with addition and subtraction, right? You either add or subtract the same value in order to get a phantom 0. But now we're trying to get these to be phantom 1. And it would work the same way with like a fraction like this. So for example, if I had the fraction 1 over negative 5, something like this. Okay, well, because I would want to make this a phantom 1, I would multiply this by negative 5, and then what happens is the negative 5 becomes divided by the negative 5. The green negative 5 divides by the orange negative 5, and then all you're left with is a 1. See, that makes a phantom 1 right there, okay? So this is how we force values to be 1s. Now, where is that value going to be in the equations? It is in a specific location, by the way. It's specifically the coefficient. If we can force a coefficient to be a phantom 1, it pretty much ends the problem, okay? Generally speaking. Now, a coefficient's not a very common word that's used, except in a math class like this. So what is a coefficient? A coefficient is a number being multiplied by a letter. So here's what I mean. If you had like 27x down there in the bottom left, you would have divided both sides, and then you would have had eventually a 1x, which is what we want. So there can be phantom values. Yeah, phantom values, because we don't really want to show ones like that. We would make it a phantom 1 if it's being multiplied by the letter. Okay, now before we get into the notes here, you'll need to keep in mind that as I write these stuff down, because some students are asking questions and then I ask to look at the notes, and you guys aren't writing down jack squat, okay? You guys got to be writing this stuff down so that when you have questions, I can refer to the notes that we took in class to help you do the problems that are on the assignment, okay? But the objective today, we're using multiplication and division as our one principle of equality to solve these equations. It's to make phantom 1s. So we can specify that here as well. Remember the principle of equality, whatever you do to one side of the equal sign, there we go, you must do to the other side of the equal sign, okay? Whatever you do to one side, you just got to do to the other side, okay? Equal sign. There we go. Okay. All right. So yeah, remember, and yeah, again, let's go back here. Anything times 1 is itself. So let's take any number. Again, this is kind of an example here. Let's take negative 13 fourths, okay? If for some reason I wanted to multiply that by 1, which I could, then it would equal, as it turns out, negative 13 fourths. Now what we did right there is, all I did is make this times 1 a phantom 1 right here. It's still there. It's multiplied by 1, but this is what we mean by phantom 1. We don't have to show that times by 1 if we don't want to. We can if we want to, but we don't have to. So here's our first problem, okay? Negative 8x equals 72. But we want the value of x that would make this true, okay? So the principles of equality, what they really tell us is what we do to one side, you got to do to the other side, right? Now remember, our objective here is not to have negative 8x's. What I would really like from this is just one individual x all by itself. And so the coefficient of x, I want it to be a 1. And then once I make it a 1, I'll make this 1 a phantom 1. Because anything times 1 is itself, okay? So that's what we're doing in this one is I want to make this negative 8 coefficient of x a 1 coefficient of x, because then I'll force that 1 to be a phantom 1, okay? So how do I make a negative 8 a 1? Once again, you have to use either multiplication or division to do this, but I'd have to take negative 8 and divide it by itself. Negative 8 divided by negative 8. It's just, remember, this is a principle of equality. I just did this, divide by negative 8. So if I did it to one side of the equal sign, I must do it to the other side as well. So the 72, I also must divide by negative 8, okay? Now what you'll see is when teachers do this, they'll say the negative 8 divided by negative 8, and then they'll cross it out like this. Sometimes they may even say something like it cancels out. It doesn't cancel out. It becomes a 1. Negative 8 divided by negative 8 is 1, okay? But now the other side of this, I'd put in my calculator, 72 divided by negative 8, enter. And then the calculator says, look, if you're going to do that, then the x value will be negative 9, okay? Now this is pretty much the end of the problem, except what we want to do is just make sure that x equals negative 9 is the actual solution to the original equation. So I'm going to go to the original equation. Negative 8x equals 72. Okay, but right now, we're pretty sure x is negative 9, but we want to make sure that it is. So I'm replacing the x with negative 9 here. And then I put a question mark over my equal sign, because I don't know for sure if this is going to be true or not. But negative 8 times negative 9, you can do that in the calculator, is actually 72, which last time I checked does actually equal 72. This right here that we have is a true statement. And now that I know it's true, I can go back to my problem and I can box this in, okay? Now again, at this point, I would want to make that, instead of it being 1x, I'm going to make that purple 1 a phantom 1, just to make this look a little bit better. X equals negative 9. Again, this is just kind of like a math nerd thing. You technically could keep the 1 there if you'd like. You don't necessarily have to. Math nerds like me, we don't like to see that 1. Actually, it doesn't bother me, but most math nerds it does, okay? And then we check, just like down here, okay? So just kind of to reemphasize what we talked about last time is when you have an equation like this, or when you found your solution, what you think is the solution, because a lot of students come back and they're like, hey, Mr. Sal, is this the correct answer? All I'm going to do is tell you to check to make sure it's true. Because if you've checked to make sure it's true, then you don't need to ask someone like me, or anyone for that matter, if it's true or not. You can know for yourself if it's true right now. You don't need the help. You can be independent like that, okay? So take this extra step just to make sure these are true. Because if it's false, if I went in here and I said, oh, 71 equals 72, that's false. Then somewhere up here I made a mistake. Maybe even it was in the checking. Maybe I typed it into the calculator incorrect. And that's why it gave me a false statement. But you have to find out why it's false, because if you get something that's false and put that into Canvas, it's going to tell you also, hey, this is wrong, but you already knew it was wrong because you got a false statement there, okay? All right, for problems like this one, these types of problems tend to cause more problems than really I would think it would. But what I would really want you to figure out on this one is what is the coefficient of just t right now, okay? A lot of students struggle with this because this is kind of a new concept, although we did cover this in the last unit. We say, well, it's a negative t, and some students would even say that there is no coefficient, but there is. You just can't see it. This is a phantom 1 right there. Of course, it's negative because of the negative sign, but it's a negative 1t equals negative 19. Now remember, our objective here is to, yeah, this is going to bring down the equal sign. But what we really want is 1t, not negative 1t. And then once this is a phantom 1, a positive 1 coefficient of t, then I can make it a phantom 1, okay? But until this negative 1 coefficient of t becomes a 1, I can't do that. So how do I make a negative 1 a positive 1? Well, it's the same thing that we did on that last problem, where we divided both sides by, negative 8, right? So I'm going to show the division a little bit differently on this one, okay? And this may help us with the next couple problems, but what I'm going to do is I'm going to take that negative 1 and I'm going to divide it with a fraction by negative 1, okay? Now, on the last problem, I actually showed the division sign. This is still a division sign. It's just shown in a different way, okay? So on the right side, I got negative 19. I'm going to divide that by negative 1. Okay, now what happens here is negative 1 divided by negative 1 on the left side there becomes a phantom 1, or 1 for now, okay? We'll make it a phantom 1 later. So this is how I get this positive 1, but on the other side, on the right side of the equal sign, we also had to divide by negative 1. So you can type this in, negative 19 divided by negative 1, enter, and then the calculator says, hey, if you're going to do that, then you get positive 19. See that? But I do want to check on this as well, okay? So let's pull out a little bit, and let's go back to the original equation. Negative t, it needs to equal negative 19. But right now, we're pretty sure if you replace t with 19, you'd get a true statement. So let's try that. Let's replace the t with 19. I'll use parentheses to show the t. And then we're questioning to see if this is true or not. Well, negative, and you can type this into the calculator, negative sign with parentheses 19, and the calculator will punch this out as negative 19, which still equals negative 19. That's always going to be true. And since it is a true statement, now I can go back and box this in. And even though I'm boxing this in, I'm going to make that coefficient of t now a phantom 1. Remember, that 1 is still there. It's still right there. You just can't see it. So in checking this, right, we said t equals 19. This is definitely the solution to the original equation. But remember, what this means also is that there's any other value of t, if you replaced it here, would give you a false statement. There's lots of wrong answers here is what this is saying, but this is the only one that would make it true. So on those last two problems, we use multiplication, or division rather, on both of those problems, okay? The division principle of equality. Now on this one, we got 19 equals x divided by 7. We want to know what value of x will make this true. And just remember that division, that fraction sign is a division sign. So you can put those dots there if you need to show that it is division. If you don't, then don't, okay? But I'm not going to put them on. But if you want to, you can. Now what I end up with here is x divided by 7 equals 19. And by the way, some students get this confused. They're like, well, the x is on the right side. Yeah, it's true. What I'm writing here on the right is exactly the same equation. It's just shown in a different order, and that's okay. So I'm going to do this twice to show you that it doesn't matter how you write this, as long as it is the same exact equality, okay? Now, I'm going to do all the work on the left first, okay? So for this one, what we do, since this is x divided by 7, I would multiply this side by 7. Now remember, if you do it to one side, you're going to have to do it to the other side as well. I'm going to show the 7 right there. So what happens here is, right here I got 7 really divided by 7, even though it's multiplied by 7. What I have is 7 over 1. And then I can cross simplify those 7s right here. And then you're just left with really what is x divided by 1. But we know anything divided by 1 is itself, right? So I get the x. In fact, remember how I cross this out with kind of a diagonal line? That's a 1. That's a phantom 1 right there. So now I get 1x equals, that's 19 times 7. Let's go to the calculator for that. 19 times 7. And yeah, my calculator says 133. It's positive. Okay, so x should equal 133. If it's true, I'll come back and I'll make that purple 1 a phantom 1, okay? But for now, let's check. Okay, so 19, it needs to equal x divided by 7. But we just found that x is 133, okay? So I replace x here with 133. Then I'm just checking for truthfulness, okay? So is this going to equal 19? So on my calculator, I can even put it in as a fraction, n over d, 133 over 7. And before I push the enter button on my calculator, I'm pretty much expecting this to show me 19, okay? Because that's what it should equal. I push enter, it says, yes, it is 19. And 19 does equal 19, that's true. So once again, we have found the solution to the original equation. There's only one solution here. And now that I have that, I'm going to make that, instead of it being a coefficient of purple 1x, I'm just going to make that a phantom 1x. Okay? But it is a solution. So I'm going to show the same thing on the other one. Okay, so I'm going to take a bit of a shortcut. Instead of showing this as times 7 over 1, because it's fraction multiplication, because it was a fraction, I'm just going to multiply this by 7 and this side by 7. See, there's the phantom 1. 1x equals 19 times 7. We already did that. It's 133. And that's a true statement right there. Okay. So if you replace x here with 133, you can get a true statement. What if there's a decimal in the values? Yeah, that's not a problem. It shouldn't be a problem. We've seen this before, solving equations last time with addition and subtraction principles of equality. Now we're looking at it with multiplication and division. In this case, though, remember, this is divide by 22.4. And just, I can't emphasize this enough. If you prefer to see that as a division sign, then show it, okay? But since it's divided by 22.4, to make it a phantom 1, I'm going to have to multiply this side also, this side by 22.4. But if I multiply that right side by 22.4, I'm going to have to multiply the left side also by 22.4. This will make that divide by 22.4 a phantom 1. So we got a phantom 1, x. Okay, because I still got the x right there. But this then equals, so I go to my calculator, I type in 22.4 times 21.2, enter, and I get 474 and 88 hundredths. Now this should be the solution to the equation, but let's just double check. Okay, so I got 21.2. It should equal x over 22.4. But right now we're pretty sure x equals 474.88. So I'm just going to put this into the calculator, and I'm testing for truthfulness right here. So there's my question mark. 474.88 divided by, you could use the fraction button as well, but I'm using the divide button. Divide by 22.4. And again, before I push enter, I should expect to see 21.2. And when I put that into the calculator, I do. 21.2 actually does equal 21.2. That's true. And since it is true, now I can box this in with confidence. And I'll even make that coefficient of x a phantom 1. Now remember, on Canvas, you do not have to write the equals x part, but if you're doing this by hand, I would. Okay, so on Canvas, all you're going to need to put on there is the number right here. All right, what do we do with fractions? Because fractions tend to destroy lives probably more than it should. But yeah, we're going to use principles of equality to solve this one still. But again, the objective here to solve it is to make it a 1g equals something. Remember that that line brings down the equal sign, right? But right now, the coefficient of g is 5/3. It's a fraction. Garbage. We don't want it to be a fraction, okay? We want it to be a 1, so we could make it a phantom 1. So how do you make a fraction a 1? Well, this is where we go back. Remember that slide. Anything divided by itself is 1. So the 5/3, even though it's a fraction, you can still divide it by 5/3 to make this a 1. Okay, remember this crossing out business, that is a 1 right there. It's just kind of slanted. It's kind of sloppy because it goes through stuff. But we divided the right side by 5/3, so we have to make sure to divide the left side also by 5/3. Okay, now I'm going to type this into my calculator with the fraction button. N over D, 55 over 9. Make sure you get out of the fraction, and then I'm pushing the divide button. and I need another fraction, so n over d 5/3. I push enter, and the calculator will simplify this for me directly. It shows me 11/3, okay? Now, if we've done this correct, then we should get a true statement if I replace g up here with this 11/3. Let's see what happens. 55/9 should equals 5/3 g's, but the g we're going to replace with 11/3. So I'm going to put in parentheses. By the way, if you're not sure what operation is between the 5/3 and the g, remember, it's not showing the operation between the 5/3 and g, which means it has to be multiplication. Multiplication is the only operation that does not have to be shown. Okay, so I got a question mark over the equal sign. I just want to see what this is. In my calculator, 5/3 times 11/3. Enter, and I do. I get 55/9 on that. Just like we thought we should. 55/9. Yep, this is a true statement. So once again, since I found that the value of g that I thought was the answer, it is the solution. And then again, I'll make that a phantom one there, okay? So here's a new type of problem. It kind of looks like that last one, and it pretty much is the same kind of thing. I'm going to do this twice, just to show you that you can do this two different ways. Now, the first method is kind of the direct method, using principles of equality that we have, multiplication and division for today. But it's going to take two principles of equality, both of them, okay? So I'm going to start here on the left, and I'd say, first of all, for me, I wouldn't want that divide by 28. So how do I make that a divide by phantom 1? Just like we've seen, you'd have to multiply that by 28, okay? Now, if you do it to the right side, you're also going to need to do it to the left side as well, okay? So I got 28 times 145 over 36. Now, remember, on the right side, that becomes a phantom 1. So all you're left with there is the numerator of 5x. A little bigger. Okay, so right now I got 5x equals, but let's put this in the calculator. So 28 times the fraction 145 over 336. Enter, and my calculator, it will simplify it for me as 145 twelfths. Yep. Now at this point, I don't want 5x's. Remember, our whole objective here is to get 1x's. And so, in order to get this 1x, I can't have a 5 be the coefficient of x like I do here. So how do I make that 5 a phantom 1? So again, I'm going to show the division just a little different. I'm going to show it as divide by 5 this way. You know, I take that back. I'm going to show it as divide by 5 like this. Now, since it's the black 5 divided by the purple 5, division, the order does matter. So the 145 over 12, I will also need to show that as divide by 5 here like this, okay? So 5 divided by 5 is 1, just like we wanted right there. This 1 right there is this 1. But in my calculator, I type in 145 over 12, and then I push the divide button, 5, enter. And once again, the calculator simplifies this for me as 29 twelfths. Okay, so let's go back here. Let's show the original equation and see if this will make, if 29 over 12 would make it true if I replace that with x. So it was 145 over 336. It should equal 5x over 28, right? But right now, the x value, we're pretty sure if we replace that x value with 29 over 12, we should get a true statement, okay? So I'm going to put this into the calculator, and we're going to see if this makes it true. Is it going to equal 145 over 336? Again, we kind of expect to see that before we push the enter button. But let's put this into the calculator. I'm going to push the n over d button. Now we got the 5, and then in parentheses we have another fraction. So I've opened a set of parentheses. I push the n over d button again, and it shows me another fraction in the numerator. That's good. That's what we want. I type in 29 over 12. Now get out of the fraction before you close the parentheses. But then I go down to my denominator and I type in 28, enter, and it shows me, when I put that in, 145 over 336, just like we expected to. that right there, that's a true statement, okay? Since it is true, I'll box in the answer that we found, the solution, and I'll just make that one a phantom one, that's it. Now, as promised, I said that I'd do this two different ways. It's not really going to change much, like the answer is still going to be the same, but it's just a slightly different method, okay? So what I'm going to do is I'm going to take my 145 over 336 equals 5x over 20. But I'm going to take the 5x over 28. I'm going to change that just a little bit, okay? So let's get rid of that. And what we can do is we can show the 5 over 28 as a fraction, okay? And then you just kind of have the x off to the side. In other words, the 5 over 28 is the coefficient of x. So I chose, instead of to show the equation like this, I chose to show it like this. And now the problem is very similar to the last problem we did with the fraction coefficient. So to solve this, it's going to be pretty simple for us. All I got to do is take that 5 over 28 coefficient of x and divide it by itself. Divide it by 5 over 28. But if you do it to one side, again, you'll have to do it to the other side. So divide this side by 5 over 28. And now that's going to make that a phantom 1, just like we want. So you got a 1x. But now that's going to equal just the same value that we found there, 29 over 12, okay? So once again, it's the same exact answer. It's just the method is slightly different. And then, yeah, we'll make that coefficient of x a phantom 1. Okay, same answer, different method. You choose which one you want to do. You can do it in 2 steps, like we did on the left. But if it makes more sense to you to do it in 1 step, like we did on the right, then do it. So this brings us into some word problems. Nicole and her best friend found some money in a trash can. It probably wasn't money, it was probably more currency. But they returned the money and found that it belonged to 2 people, getting $82 each. Write an equation representing this situation. Your equation should be equal to 82. So right off the bat, we know that the equation is going to equal 82 like this, okay? So yeah, the 82, it has to equal 82, so there we go. We've made it equal 82. We just got to figure out what the other expression is that we're comparing with 82. Remember, equal signs are comparison of values. So what happened here? They returned the money and found that it belonged to 2 people. Both of them got the 82. So that means after they split it, okay, so the 2 people, they split it with 2 people. So that's divide by 2. So what was divided by 2? However much they found. And that's what we don't know right now. Excuse me. How much they found. So right here, I'm going to say X, that's the amount of money that was found. Okay. So I say I'm going to take X and divide it by 2. That is $82 for the 2 people there, okay? And as it turns out, that would be 1 box that you'd need to fill in on Canvas for the credit. But there's a second box. How much money did they find? Well, that means we're just going to take the equation and solve it. Okay, so that's x over 2 equals 82. Now, I don't want that divide by 2 with the x. I would like this just to be 1x. So how am I going to do that? I'm just going to multiply it by 2. But if I do it to one side to make that 1x, which it is, I have to do it the other side, which is 82 times 2 is 164. If there's a word problem, please do not forget to label your answers. And so this would be, well, really all you need is the 164 is to put in the box. If you're doing this by hand, make sure you label these though. Yeah, you can make that a phantom 1 if you want. But that means they found 164 bucks just in a trash can. I don't know. Maybe it's like, maybe it was at the end of a rainbow. I don't know. Well, they did the ethical thing and they turned it in instead of packing it, you know. But Jose spent $422 on batteries. They cost $52.75 per pack. Now, we don't know what kind of batteries these are. Maybe there's some kind of special kind. Whatever. Write an equation to represent this situation. Your equation should be equal to $422. So, the $422, that's how much Jose actually spent on this. So, it's okay to say what's going to equal 422. Okay, but what's going to equal 422? This is how much he's going to spend on the batteries, right? Well, the batteries, right out the bat, it's $52.75 for every pack. Okay, so what we're going to have to do is we're going to have to say, look, we need some kind of variable in this, and x is going to be the variable we should be using on these problems, but x is going to be equal to, well, that's That's the battery packs that Jose is going to purchase. Battery. I feel like I spelled that wrong, but I also don't care. Battery packs. So that means if you took the $52.75 per pack and multiplied it by the number of packs, then it would have costed him $4.22. And if you're ever not sure what the X represents or the variable, just look at the question. How many packs did Jose buy? Remember, that should be what we're solving for in these, okay? Now again, that's one of the boxes you're gonna have to fill in on Canvas. But the second box, how many packs did Jose buy? Well, let's write the equation out again. 5275x times x equals 422. All we got to do is solve this, and to solve it, what I really need is for it to be 1x, not 5275x. That's a decimal coefficient right now. We just want it to be 1. So to make it a 1, again, I'm going to show the division a little different on this one. 5275 divided by 5275, that's 1. But if you do it to one side, you got to do the other side as well. Okay, and let's see what this gives us. In the calculator, 422 divided by 52.75, enter. And this tells me that it looks like how many packs Jose purchased on this one? 8 packs. That's what the calculator says anyways. And again, since it's a word problem, I would label this as 8 packs. And then, yeah, I'll make that, instead of at 1x, I'll just make the 1 a phantom 1. Boom. All right, there's our objective then. I can solve equations with one principle of equality. Again, our main objective today, it's either the multiplication principle of equality or the division principle of equality in order to force coefficients to be 1s. And then those 1s will eventually become phantom 1s, okay? Now, do expect in the future to see, like we saw in the bell work, some distribution, some simplification by combining like terms of terms. And also the other two principles of equality we went over last time, which was addition and subtraction, okay?